Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at graphing using intercepts. So remember, we looked at graphing linear functions. They are functions of the form y equals mx plus b. Y equals something times x plus something. Remember, the number in front of x is the gradient. The gradient is also defined as the rise over the run. It's how much the y value increases or decreases each time x goes up by 1. And b, the number by itself, is the y-intercept. It's where the line hits the y-axis. It's also the y value when x is equal to 0. So we've been looking at turning those equations into graphs. Remember, what we've been doing is drawing up a table of values, choosing x values, finding the y values, and plotting a series of points. And those points always lie in a straight line. But that method is actually a bit time consuming because you're actually finding quite a lot of points. There's actually a quicker way to do it, and we're going to look at that in this video. So if I have my Cartesian plane, so I'm going to set it up like this. Remember, the y-axis is vertical and the x-axis is horizontal. So it turns out that if I plot any 2 points in the Cartesian plane, no matter where they are, say here and here, there is one and only one line that will pass through both of them. So I join them up. That's the only line that will go through them. So what this means is if you want to graph any line, no matter its equation, you only need to know 2 points that lie on that line. And graphing using intercepts does that. We're going to find 2 points that lie on the line and then join them up. It turns out that the 2 points we're going to use are the y-intercept, where it hits the y-axis. The x-intercept is going to be the second point. So we're going to find those 2 points, and then we're just going to join up those 2 points and we are done. Now, if it's written in the form, if the equation's written in the form y equals mx plus b, it's really easy to find the y-intercept. It's just the number by itself. But it won't always be written in that form. So we need a surefire way to find the y-intercept no matter what the equation looks like. So you find the y-intercept by letting x equal 0. Similarly, you find the x-intercept by letting y equal 0. So you just substitute that into the equation. So I haven't made a mistake. Y-intercept, you let x equal 0. X-intercept, you let y equal 0. So the reason for that is if I want to look at the y-intercept where it hits the y-axis, which is here, along this line here, the x-coordinate is always 0. So if I was looking at, say, this point here at 3, that is the point 0, 3. The x-coordinate is 0. If I, say, was looking at a point here that's, say, -2, that would be the point -2, 0. Along the x-axis, the y-coordinate is always 0. That's why we let y equal 0 to find the x-axis. We're finding the point along the x-axis that the line goes through. So let's look at an example now. Please pause and copy this down if you need. So let's say I want to graph y equals 3x minus 4. I could rule up a table of values, choose the x values and find the y values, but that can take a little while. So instead, I'm going to use the intercept method. So first step, I'm going to find the y-intercept. Well, when it's written in this form, y equals mx plus b, this number by itself is the y-intercept. Now, please understand, the y-intercept in this case isn't 4, it's negative 4. So the y-intercept is actually negative 4. And that's exactly the same as what you'd get if you let x equal 0. So if I have y equals 3x minus 4, and then I substitute x for 0, so I cross out my x and change it to 0, I get 3 times 0 minus 4, which is minus 4. Okay? So if I let x equal 0, I get that same value, the y-intercept. So to find the x-intercept, what you do is let y equal 0. So I take my equation, y equals 3x minus 4. So everywhere I see a y, I'm going to change it to 0. So that becomes 0 equals 3x minus 4. So what do I do then? I solve for x. You know how to solve this equation. Find what x is. I'm going to add 4 to both sides, and I get 4 equals 3x. Now I need to divide each side by 3, because I'm doing timesing by 3, dividing by 3. And then I get x equals 4 over 3. So 4 over 3 is like 1.3 recurring. So the third step, now that I've found them, is to join them. And that's exactly what I'm going to do now. So now I've drawn up my axis, of course, y-axis vertical, x-axis horizontal. Yours will be beautiful and ruled up. Again, I apologize, I can't use a ruler on this iPad. So now I'm going to plot the two intercepts. So y-intercept of minus 4 is down here, so I'm just going to plot that point. Now the x-intercept is 4 over 3, which is 1.3 recurring. So if 1's here and 2's here, it's going to be closer to 1, so it's going to be like about there, okay? You can just estimate it, don't have to get it exact. Now that I've got those two values, all I need to do is join them up, and that is the line y equals 3x minus 4. So just make sure you label the intercepts. So this one, in this case, will be 4 over 3, okay? And then I'm done. So I'm now just going to show you one more example. Please pause and copy this one down if you need. So now I'm going to graph the line 3x minus 2y equals 6. Now this is not written in the form y equals mx plus b. I could write it in that form, but that would take a bit of work. So I'm not going to do that. To graph this, I could draw up a table of values, but I hope you see that each time I pick an x value, I'm going to have to solve an equation to find the y value. So that's going to be time consuming. So an efficient method to do this is to use the intercept method. Find the x-intercept, find the y-intercept, and join them up. So to find the first y-intercept, we take our equation. So I haven't changed anything yet. So what I do, remember, to find the y-intercept is I get rid of x and change it to 0. So I have 3 times 0 minus 2y equals 6. But 3 times 0 is just 0, so I can just get rid of it. So it's not 2y equals 6, it's negative 2y equals 6. So y-intercept will be 6 divided by negative 2, which is minus 3. Okay? So second, I'm now going to find the x-intercept. So again, I'm going to take my equation, 3x minus 2y equals 6. So this time, I'm going to change y to 0. But if I change y to 0, this whole thing is going to be equal to 0. So I'm just going to get rid of it totally. So now the y's gone, I'm left with 3x equals 6. So of course, x would just be 6 divided by 3, which is 2. So the y-intercept's negative, the x-intercept's positive. Nothing wrong with that. And my third step is to join them, which I will do now. So I've got my axis all ruled up. I'm sure yours will look a lot better. So we'll mark the x-intercept's going to be at 2, and the y-intercept is going to be at minus 3 down here. So make sure those are labeled. So then all I do now is draw a line between those two. And I should label the line. I should write it as 3x minus 2y equals 6. How easy is that? So note this line leans to the right, therefore it would have a positive gradient. Okay, so the last thing I need to show you is actually not graphing, it's finding the equation of a line when you're given the intercepts. So we're going to find the equation of a line with y-intercept 3 and x-intercept 1. So we might draw up the Cartesian plane so that we know what we're up against. So y-intercept is 3, so that's going to be like up here. Mark the y-intercept, and the x-intercept is going to be 1, which is there. So now we're just going to join them up. So that's the easy part done. Now I've actually got to find the equation. Well, in a previous lesson, we learned that the equation of any line can be written in the form y equals something times x plus something. So what goes in the box in front of x, remember, is the gradient, which is the rise over the run. So rise is how far you've gone up or down, and run how far you've gone across. So start with the leftmost point. To get from the y-intercept to the x-intercept, I've gone down 3 and across 1. So the gradient's going to be 3 over 1. which is just 3. But remember, if the line leans to the left, the gradient's negative. So this leans to the left, and so it's a negative gradient. And that's because I didn't go from the first point to the second point. I didn't go up, I went down. So -3 just means 3 down instead of 3 up. So that's what number goes in the first box. The other number is the y-intercept, but you know what that is. That's just 3. It told us in the question. So the equation here will be y equals gradient times x plus y-intercept. So that's the equation you need to start with and graph to end up with a line that has y-intercept 3 and x-intercept 1. All right, apologies for the long video. This has been the luckiest maths teacher in the world. Have a great day.